Okay, this is your polar question. Okay, let S be the shaded region inside the graph of the circle, which I've highlighted in blue as r equals 3, and also inside of this limacon right here. Okay, there's multiple ways to do part A, but what I'm going to do is first of all do it by symmetry. So I'm going to just do like 1/2 of it and then just double my answer. One thing I notice is that this piece right here is just a quarter circle. The radius of that is 3. So I can just do pi r squared over 4 because it's a quarter circle, and I just set the radius as 3, so let's plug in 3 for r. Now, this top half of the shaded region, I'm going to go ahead and draw this angle in. This is what you should do for the polar. They tell you specifically that this is pi over 6. So notice if you're trying to find this shaded region right here, I can integrate from 0 to pi over 6, but notice the gray region is only bounded by that blue circle. So the area of a polar is 1/2 r squared, and my bounds are 0 to pi over 6. Then, in order to come up with this little shaded region right there, notice it goes from pi 6 to this angle, and I know this angle is pi half because I know limacon goes from 0 to pi half. But notice this shaded region is only bounded by the limacon. So I'm going to do 1/2 pi 6 to pi half of the limacon, which is 4 minus 2 sine of theta squared d theta. So there's my entire setup, but you want to make sure you take your final answer and multiply by 2 since I only did the right side. Use your calculator. 24.709 is my value. Part B, it says particle moves along the polar curve at a certain time for which the x-coordinate is -1. So they want you to find the time when the x value is -1. So here's my setup. X equals -1, but notice that I don't have an equation for x, but we know in polar form that x is the same as r cosine theta. So this is what you're trying to solve. They give you r equals 4 minus 2 sine theta, so -1 equals 4 minus 2 sine theta, cosine theta, but they want you to find the time t. So you can solve this right now, or I'm going to go ahead and plug in t squared for theta. So I get 4 minus 2 sine t squared, cosine of t squared. I'm going to use my calculator to solve it, y1, y2. It will cross them multiple times, find the first place it happens, because remember a polar graph you go around and around. The first value that it happens is at 1.4279. Okay, part C, find the position vector. So I need an x, and they want it in terms of t, so I want an x of t and a y of t. Again, my two equations for x and y in polar form are these, but I need it in terms of t. So let's do the substitution for r first. So r is 4 minus 2 sine theta cosine theta, and theta is also the same as t squared. Cosine of t squared, oops, parentheses, y equals same thing here. Plug in t squared for theta. Okay, there's my x, there's my y, this is my position vector, and I'm done. Lastly, they want you to find the velocity at 1.5. You will use your calculator. This is the x component. Have the calculator take this derivative and plug in 1.5 for t, and these are my two values that I get. There's your x piece, and my y velocity is this.